Very wonderful to see you all today in whatever time zone you are joining our Science Symposium from. I'm Dawn Wright, and I'm very honored to be speaking to you from here in Redlands, California, near Esri headquarters, which lies in the traditional territory of the Uhaviatum clan of the Serrano Indians, now within the federally recognized tribal government of the San Manuel Band of Mission Indians. And we are deeply grateful to these original and ongoing caretakers of this land. Let me start our show for you today. And indeed, welcome, finally, to the 6th annual Esri UC Science Symposium. This session is like many others where you can enter your questions in the chat, the Q&A portion of the platform, and we will do our best to answer those as quickly as possible. If you're using social media, please use the hashtag Science Symposium. You can also use the hashtag EsriUC. And yes, to reassure many of you, this session is being recorded, and it will be available to you within the conference platform within 2 hours after this session, including the Q&A portion. For the rest of the world, a recording will also be available on YouTube in perpetuity. And last year's Science Symposium is also still on YouTube. And in all of this, for the virtual logistics for this event, I'd like to give a special thanks to Kristen Frith of the Esri Events marketing team for her unflagging support of this event. She has been tremendous, as well as to Victoria Phillips in corporate science communication. By way of introduction of myself, again, I'm Dawn Wright. I'm Esri's chief scientist and also a full professor of geography and oceanography at Oregon State University. And as chief scientist here at Esri, I foster a program to strengthen the scientific foundation for Esri software and services, especially in the disciplines shown on the slide where we have very strong scientific expertise and productivity ourselves, while also representing Esri to the international scientific community, especially on various boards and councils and research projects. At Esri, we also work collaboratively with some of the world's largest earth science organizations, as well as with amazing individuals such as our keynote speaker. We'd like to invite you to also check out the Esri UC 2021 Q&A. This is actually a hidden gem. It's one of the single best sources of information on Esri as a company and on our products and services. It's also based on your questions that were sent to us prior to the UC, and it's still available online and searchable. So you can go to the URL that is in yellow here, and you can put in a search term such as geographic science, and it will return to you valuable information that focuses on specific ArcGIS capabilities and tools, especially for scientists. Realizing that for many of you, Twitter is your preferred discussion forum, as well as the place to get news and content, we also have a popular presence on Twitter at GIS and Science, as well as my personal account, Deep Sea Dawn. Though be warned that if you go to Deep Sea Dawn, you will also find in my feed other fun content, including Legos, professional cycling, and the adventures of my puppy dog, Riley. But there's a lot of science on there as well. We also have a very extensive online science portfolio, and that continues to evolve at this URL that you see, esriurl.com/SciComm. It was also the subject of my first column in Arc News, and you can get the link to that column in the notes that I will be making available to you in a few minutes. And our program at Esri in terms of science continues to evolve around 6 major initiatives. So we're working very hard on open science, weather and climate science, ocean science, solid earth science, which includes hydrology, agricultural science, terrestrial ecology, terrestrial geology and geophysics, soil science, and a lot more. Geographic information science, which is also becoming increasingly known as spatial data science. And so that includes remote sensing, cartography. There's information about our new relationship with the Group on Earth Observations, or GEO. And social science, with new sections in this portfolio on the coronavirus response and also racial equity and justice. And we will be having a forthcoming emphasis on qualitative social science. In fact, on Tuesday we had a terrific tech workshop to launch our new qualitative social science initiative, and that workshop was called Enhancing Qualitative Social Science Research with GIS. And in the notes that you'll see, you can get a link to that recording as well as to the story map that describes that session and that initiative. And as you know, our conference theme this week has been GIS Creating a Sustainable Future. And our science portfolio is actually really the only place in all of Esri.com that points to Esri's own environmental and sustainability statement, which provides a glimpse of what we now have going on behind the scenes in terms of our sustainability strategic plan, our sustainability projects internal to our company, our performance reporting, especially our continued targeting and relentless reduction of greenhouse gas footprint, our greenhouse gas footprint across the company, as well as our own internal ECOS employee resource group. We're also very proud to announce a new microsite on Esri.com, which is on climate action planning, and there are sections on this new site about evaluating impact, assessing risks, mitigating and adapting to climate change, and of course, taking action. And in the coming weeks, this microsite will be directly linked into the Esri Science portfolio as our 7th initiative. Now, Jack briefly shared on day one this awesome project, which is driven by the need for trusted, accessible, and high-resolution global land cover. So there's the new 10-meter resolution global land cover 2020, and this is going to be, we hope, a game changer for conservation planning, for monitoring change, for all kinds of environmental applications. And we've collaborated on this project with Microsoft, National Geographic, and the Impact Observatory, which is a company that you may not have heard about. The Impact Observatory brings machine and deep learning algorithms and data to bear for sustainability and environmental monitoring. So, as I mentioned, this project uses a 10-meter near cloud-free mosaic produced with Microsoft and the Impact Observatory using Sentinel-2, and it's hosted on Esri's Living Atlas, as well as on Microsoft's Planetary Computer. And in addition to this, my colleague Sean Breyer and his Living Atlas team, in collaboration with Clark Labs at Clark University, have also just yesterday released Esri Land Cover 2050. And this is a series of maps that aims to predict land cover change into the year 2050 based on decades of satellite observation data from the European Space Agency's Climate Change Initiative. And this map series has been created under a Creative Commons license, so it opens up the use and consumption of the maps in alignment with our commitment to open science and open data. So there's also a link to that initiative, as well as how to get to the high-resolution global land cover in the notes. Now, at the prior two science symposia, we were pleased to announce the publication of the books GIS for Science, Applying Mapping and Spatial Analytics. We released Volume 1 in 2019 and Volume 2 last year. And this has been a tremendous undertaking and an even bigger pleasure to work on these books with my co-editor and lead layout designer Christian Harder, along with the terrific editorial assistance of Mark Henry and Keith Mann of Esri Press. And if we were all together in person, I would have them stand up and get the thunderous applause that they so richly deserve. But alas, we are, of course, in this virtual format, so I hope that you will give them some applause where you are within Zoom. But I really thank these colleagues for helping these books become a reality, working with me and with so many scientists, because this is not your average scientific book series, we feel. It's a series that has featured a somewhat unique format in that these books are not just dry research monographs. They are not just atlases. They're actually, as Christian describes them, a cross between Wired magazine and National Geographic, but written in the more open language of Scientific American, and with stories written by top-rated scientists about how many things GIS, including geospatial data science, are a true force multiplier for great science writ large. So each book features these amazing stories with a lot of rich visual content, especially in two-page graphical or photographic spreads. And there's also a special technology showcase section at the end of each book, which features vignettes about Esri's own contributions to science. And Volume 2 includes an additional special section on the GI science response to COVID-19. Now this year, I'm very, very pleased to announce the forthcoming publication of the third and final volume in this series. It's newly entitled GIS for Science, Volume 3, Maps for Saving the Planet. So this third volume pivots even more sharply than the prior two volumes to focus on biodiversity. It follows the same format, but consists of stories by scientists such as our keynote speaker and her colleague Regan Smythe, who are literally creating the maps that are helping to save this planet. These stories really focus on biodiversity through the lens of global satellite observation, forestry, marine policy, artificial intelligence, and of course, conservation biology and environmental education. So each one of you today attending this session as a special treat for joining us in this session, especially those of you who are joining so very, very early in the morning, you will or you are going to receive a pre-release copy of this book. Actually, we're going to give you the link right now. And the pre-release copy is in the form of a flip book. Really cool. It's something that you only need a web browser in order to enjoy the book. You don't have to download anything. We do ask you, though, not to distribute the link widely, not to distribute the link actually at all, because we're still working toward the final version of the book that will be officially on sale in both print and e-copy sometime in October. So what you are receiving now is an uncorrected proof intended just for this special event. And so now, with a drum roll, are you ready for the link? This is the link that you can go to in order to get the flip book. Again, you don't need to download this. This is something that you read in the browser. And I'm going to pause for a second if you want to take screen snapshots or write down this link. It's go.esri.com/GIS-4-science-3. And we hope you really, really enjoy this. The entire book is in this flip book format. So from cover to cover, you can read about these amazing stories and see more about the fantastic technology that has been brought to bear. In addition to this, a site that is completely public and is live right now is the book's companion website at gisforscience.com. And this is a companion to all of the chapters that are featured in Volume 3. There are a dozen chapters, and there are 15 technology showcase vignettes by Esri staff. There are literally hundreds of data sets and web maps and apps and story maps and videos, workflows, Python notebooks, journal articles, many of them open access journal articles, learn lesson tutorials, and much more on this very, very rich companion site. In fact, a lot of people tend to use this companion site a bit more than the book itself. We've done this to, of course, supplement what the authors have written about, and to also offer this as a supplemental teaching and research resource as well. So please go to gisforscience.com. Now that concludes all of the announcements, and finally I want to get to the heart of the symposium, so I'll take just a couple more minutes before I turn things over to our speaker. Again, if you are live tweeting, please use the hashtags in the upper right here, hashtag Science Symposium, hashtag EsriUC. And if you want the slides that I'm presenting to you, you can go now to esriurl.com/symposium21. We have had a marvelous time with this event. It's been a highlight for so many of us. And in the first 3 years of this event, we followed a format where the chosen keynote speaker was not a GIS specialist, and we did that by design. We chose noted scientists who had a strong, compelling vision for improving and protecting the planet, along with a very healthy respect for GIS, geospatial technology. Then we followed those keynotes with a conversational reaction panel that was deliberately made up of GIS specialists so that they could respond to the vision of the keynoter from the perspective of geospatial and discuss further how best to use GIS to implement the vision laid out by the keynoters. And this was a lovely format to have, especially in San Diego, in person with the hundreds of attendees. In 2019, we went to a bit of a different format where we featured a tag team of 2 top scientists who also have deep GIS expertise, and they spoke on the topic Science in Service to Society, and they focused on climate risks. But instead of having a reaction panel, we went straight to Q&A, especially so that we would have enough time for the beer and the bubbly and the snacks afterwards. Last year, of course, you know that everything was virtual. So we had a virtual format for the Science Symposium as well, and we had just enough time in that format to enjoy the presentation of the award-winning climate scientist Katherine Hayhoe, and then went straight to Q&A there. And we will be using that same format this year. So we are going to now have a wonderful, beautiful keynote address by my friend and fellow chief scientist, Healy Hamilton, Dr. Healy Hamilton of NatureServe. Now, I hope you are already familiar with NatureServe, but if not, NatureServe is a Western Hemisphere biodiversity information network, and it's focused on the management and conservation of at-risk species and ecosystems. Now, Healy is a biodiversity scientist by training with graduate degrees from Yale and UC Berkeley, and she has extensive field experience in the tropical forests of Latin America. So at NatureServe, excuse me, had to take a water break there. At NatureServe, she leads a staff with expertise in ecology, zoology, botany, conservation, data science, and information management. And together, they deliver these amazing foundational informations on the distribution, the conservation status, and the trends of species and their habitats. Now, Healy is also a world expert on the taxonomy and evolution of seahorses and their relatives, which is why I'm wearing my special seahorse t-shirt for her today. Healy is also an elected member of the Executive Committee of the IUCN U.S. National Committee. She's an honorary fellow of the World Conservation Monitoring Center. She's a contributor to the IUCN Species Survival Commission for Seahorses and Pipefish, and a member of the Key Biodiversity Areas Committee. Healy is the recent past president of the absolutely awesome Society for Conservation GIS. She's a Switzer Foundation Environmental Leadership Fellow and a former U.S. Fulbright Scholar. And as mentioned before, she is a contributing author not only to Volume 3 of GIS for Science, but she is also featured in another Esri Press Volume 3, that is the Women in GIS Volume 3, Champions of a Sustainable World, that just came out. So, with no further ado, let me hand over now to the fantastic Healy Hamilton. And Healy, thank you so much for joining us. Welcome, and take it away.
Dawn, my goodness, thank you so much for that fabulous introduction. And I was so pleased to hear all of the introductory comments you had about the important work that Esri is doing on open science and all the different initiatives that you have underway. It's been an amazing week at the UC. I look forward to seeing a lot of sessions that I missed on YouTube later. So it's wonderful that you're providing that opportunity. I am so honored to be in this incredibly prestigious venue, to be able to share with you some of my thoughts about biodiversity. It's the theme of the next and last in the series, GIS for Science book, and it's very appropriate that it's the theme for my talk today. And I am greatly honored to be on this stage, able to share not only some of my thoughts, but some of the work that NatureServe has done in the field of biodiversity conservation, leveraging a network of experts and data science, spatial data technology, and tools. So let me quickly here try to work the technology to share my screen, but of course it has to be the right screen. And give me one moment. So I'm going to stop that share for a second, go back to the PowerPoint, get the right screen going. This is always the most stressful part of starting a keynote. All right, now share the right screen and we should be good to go. So Dawn, can you confirm, or someone confirm, that you are seeing the correct title slide screen? Thank you so much.
Looking great.
Okay, so, I mean, I really wish, of course, that we could all be together in San Diego and that we'd have this opportunity to see and interact with one another in person. But we've all adjusted as best we can to this virtual form of communication. And often we found that in many cases, it actually extends the inclusivity and the reach of our messages. So I appreciate that you are willing to engage in yet another remotely delivered presentation. I encourage you to use the platform that Esri has offered in order to send any questions or comments that you have at any point during this talk, as we will definitely leave some time at the end for discussing your reactions to any of the material that I present here today. I also ask that you bear with me regarding any delays that you might experience in the streaming process as my data goes from here through Esri's system to your system. But I will do my best to maintain sort of the experience of you being connected to what you're seeing and hearing as the presentation moves through. So my talk today is divided into 3 sections. So first, I know that everyone listening here today understands that biodiversity is important, but I'm going to take some time to provide just a few examples to maybe remind us more deeply of just how much the well-being of each of us individually, of our communities, of our societies, and of humanity itself is utterly dependent on the natural world, even though we don't always behave and acknowledge that truly incontrovertible fact. So given that the conservation of the diversity of life is so essential, I'll talk a little bit about approaches we use to understand its status and achieve its conservation. And then finally, I'll turn to the story of NatureServe and how we are leveraging people and data and technology to become more spatially precise with our conservation information, so we can better balance the sometimes competing needs of conservation and economic development. So let's start with the basics, right? We don't often think in these terms, but every single calorie ever consumed by all of mankind in all of human history comes from biodiversity. And supplying enough safe and nutritious food for a rapidly growing world really requires that we increase food production globally without undermining the planet's capacity to meet the needs of future generations and to deliver other essential ecosystem services that we'll talk about more a little later. What is a solution to this challenging balancing act? It's diversity, which our current food production system does not leverage. There's tens of thousands of edible plant species, but only a few hundred that contribute significantly to our current food supplies. And literally so many of our calories come from just 15 crop plants that are feeding about 90% of the food energy intake for the world. And just 3, rice and maize and wheat, are the staple crops for over 4 billion people. But we know that as climate patterns change, the conditions for growing crops change as well. And the yield of our principal food sources becomes less secure. And this is especially true when so many people depend on so few species. So here's an example of a culture that is reversing that trend. The Dongriyas are one of the most traditional tribes of India, and they live in remote hamlets that are scattered throughout the Niyamgiri hill range in southern Orissa, which is a state in the country's eastern limb. And they once grew a diversity of what are now considered heirloom rice varieties, but they started losing their self-sufficient food systems when the forest became degraded due to logging, and the government introduced and subsidized these high-yielding rice varieties. So from historically a diverse indigenous farming system, the Dongriyas gravitated towards rice monoculture, and they lost some of the diversity and resilience of their food production system in the process. But following a series of recurrent droughts and erratic rainfall that led to an agrarian crisis, the Dongriyas are on a mission now to return to their farming roots. So they have a renewed sense of their rights after they successfully ousted a UK-based mining company in a much publicized resistance in 2013. And with a little help from a grassroots organization called Living Farms, the tribe began resuscitating their lost seed varieties. So they now sow close to 50 different varieties of seeds that are intermixed on a single farm: millet and grains and pulses and beans and oil seeds and tubers and vegetables all together. They've created a seed bank and a seed exchange program in recognition of the simple fact that diversity equals food security. And in a rapidly changing world, this statement applies not just to the Dongriya culture in remote hills of Eastern India, but to all human societies, especially those that are most vulnerable. And of course, our food security does not just depend on the crops we plant and harvest. Biodiversity itself is a partner in agricultural productivity. We cannot reap what we sow without the pollination services that we receive for free from ants and from flower flies and moths and bees and birds and mammals. There's been an increased focus in the last couple decades on studying the economic value of nature's pollination services. And the numbers are completely staggering. I mean, I had to put all of the zeros onto this slide so that we could see that the biodiversity services that are provided for free by pollination, they're estimated to range from $200 billion to $400 billion every year. That is not a replaceable service. Food security and pollination services are a foundational delivery of a foundational gift from the diversity of life, but that's not all. Evolution has produced an almost inexhaustible array of molecular entities, which in turn provide sort of infinite resources for modern science to use in drug development. And there's been billions of years of chemical evolution, and it's produced a pharmacopoeia that is far more advanced and creative than what we can think to synthesize in labs. So literally since time immemorial, natural products have been the backbone of traditional systems of healing throughout the globe, and they still are today. About half of the drugs approved during the last 30 years are either directly or indirectly derived from natural products. Here's why it matters about the diversity of species that we can use to apply to medicines. This can only be true if the diversity of life is sustained. So an example of the medical cost of extinction is the gastric brooding frog. This was discovered only in 1972 in the mountains of Queensland, Australia. In 1974, scientists discovered how it reproduced. The mother frog converts her stomach into a womb. She swallows her own eggs and stops making hydrochloric acid in her stomach to avoid digesting her own young. So then over the next 6 weeks, around 20 to 25 tadpoles hatch inside of her and grow, and eventually she throws them up, spews them into the world as fully formed little froglets. If this amphibian could deliberately stop making acid in its stomach, it might provide new ways of treating ulcers. But the frog was last seen in the wild in 1981, and the last captive individual died in 1983, and the species was gone. It's no more. This is their habitat in the Queensland forest of Australia that's threatened by feral pigs, invasive weeds, polluted waters. The chytrid fungus also probably played a role in their demise. It's not just species on land, but also from the ocean that have incredible potential as future medicines. So sea cucumbers, which are not exactly as cute and cuddly as seahorses, they have amazing properties that may lead to future treatment for stroke victims.